For this lesson, we're talking about zero and negative exponents. For this lesson, it's important to understand a few different rules. First of all, and I have the rules up here in the top left corner, any number to the 0th power in math is considered to be equal to 1. So really simple, just remember that anything that is to the 0th power is equal to 1. Next, we have that any value to a negative exponent is equal basically to its inverse. So this would be 1 over n to the positive second power. And we can also see that anything such as this, so 1 over n to the negative second power will equal n to the second power. So that n to the negative second power that was in the denominator will move to our numerator, becoming n to the second power over 1. Well, any number divided by 1 is that number. So that's why we just wrote n to the second power. So let's see some of these problems. Something to keep in mind is you need to identify what is the exponent really associated with. So in problem 1, we see negative, open parentheses, 2.57, close parentheses, to this 0th power. So what is going to the 0th power? It's just the 2.57. Since that negative sign is outside of the parentheses, we don't work with that until we found the value of 2.57 to the 0th power. Well, any number to the 0th power is 1, so I write down 1. But since that negative sign was on the outside of the parentheses, that problem is negative. So our answer to number 1 there is negative 1. Moving to number 2, we see negative 3 to the negative 4th power. Well, since that negative sign, again, it is not necessarily associated with that 3. In order for it to be associated with it, it would have to be within parentheses, similar to problem 3, where we see negative 5, but the negative sign is in parentheses with it. So what will happen is, since we have a negative 4 here as the exponent, it's going to send that 3 to the denominator. So it's going to become 3 to the 4th power, but that is underneath 1. And again, since that negative sign, we haven't worked with that, and since it is not in parentheses, that negative sign we could just put out in front of our fraction. So right now it is negative 1 over 3 to the 4th power. We could simplify this, since 3 to the 4th power is something we can accomplish. We can write negative 1, and then 3 to the 4th power is 81. So for that problem, we would get negative 1 over 81. For number 3, we see this one as an example with the negative sign in parentheses. So again, we'll move it to our denominator. So we're going to put negative 5 to the second power because that negative exponent becomes positive, and it is underneath 1. From there, we could simplify, well, negative 5 times negative 5, since that's what it means with the negative being inside of the parentheses. We will get positive 25 as our denominator and 1 as our numerator. A helpful trick is to remember that if a negative number is raised to a power, then it's going to be positive anytime it is to an even number. So since it's to the second power, 2 is an even number, then the outcome is going to be positive. But if it's raised to an odd power, such as 3, so negative 5 to the 3rd power, would be a negative number. Moving on to number 4, we have a fill in the blank. So the red lines there, we need to figure out what do we need to input in order to make this true. And well, what we need to identify is what numbers have changed places. Okay? So if we look, we can look at this x. Well, prior, or well really on the right side of our equation, we see that x is to the negative 3rd power. Well, x is now in my numerator. I've switched it, which means we're going to use those rules that since x was to the negative 3rd power over here, if it's now in the numerator, that is the same as saying x to the 3rd in my numerator. Then we look and we see, okay, well, I see the 2's are the same. I have a y that I need to fill in. Well, the y was in the denominator on this side, so it hasn't changed places. So that means in order for that to be equal, that needs to be the same value. Over here, we had that 1 in the numerator. That was because we didn't have anything else in our numerator, since our x was to the negative third power in our denominator, so that's why we had a 1, and it disappeared over here because we don't need to have 1 times x to the third power, because any number times 1 is that number. So x to the third power is indeed the same as x to the third power times 1. For number 5, for these problems we're simplifying. And what that means is we are going to eliminate any zero exponents, and we are going to eliminate any negative exponents. So what I'm going to do is I'm going to just start going through. I'm going to say the number 6. The number 6, there's no exponent associated with it. So we could just say that would be 6 to the first power. Well, that's positive, so that's going to remain in my numerator. Over here, I have a to the negative first. Well, I want to eliminate negative exponents, and so I'll write a fraction bar, and my a will move to my denominator. Now, since it's a to the negative first power, it would become a to the first power in the denominator. A to the first power is just a, so I don't need to write an exponent. Over here, I have c to the negative third power. Well, since it's a negative exponent, I want to move it to the denominator. So since it's c to the negative third in the numerator, it will become c to the positive third in the denominator. D to the 0th power, anything to the 0th power, is the number 1. So d to the 0th power equals 1, and since any number times 1 is the same number, I don't need to write that. So our answer here, and I'll clean it up a little bit, is 6 over a times c to the 3rd power. In our last problem, we have 3 different variables, but we also have a negative exponent with a coefficient, with a number. So let's take a look at what that would do. Let's look 7. 7 would be 7 to the first power. That stays in the numerator. S to the first power, S to the 0th power is 1, so I can just leave that 1 off because any number times 1 is the same number. T to the negative 5th power, that's going to move to my denominator, so I'm going to put a fraction bar. It's t to the 5th power, since I just removed the negative sign. I look here and I see 2 to the negative 1st power. Well, what will happen is that needs to move to my numerator, and I'm going to put a multiplication dot here because if I don't, it might look like I'm just writing the number 72, but that is not what it equals. It equals 7 times 2. I need to look at m to the 2nd power. Well, that is positive exponent, so that remains where it is. That remains in my denominator. And we look at this and we have to wonder, is there anything else we can simplify? The answer is yes, because we know how to do 7 times 2. 7 times 2 is 14. We get t to the 5th power and m to the 2nd power. And that wraps up these example problems for 0 and negative exponents.